Jai Jinendra, Namaste and welcome to my channel. Today we are going to solve the 83rd question of the problem solving series and the 8th question of the topic linked list. The difficulty level for this question is medium and this question has been asked in Google, Amazon, Microsoft, Meta, Adobe and Apple. Remove nth node from end of list. Okay. So we are given the head of the linked list and the value of n, and we need to remove the nth node from the end of the list, okay, and then return the new linked list, means the changed linked list. So here in this example we have this head and this list is given and this head is pointing to 1 and this is the list 1 2 3 4 5. We need to remove the nth node from end of list. That means if we start from end, so the second one from the end we need to remove. That means this is the first this node and this is the second node. So this pointer, this 4 element we need to remove. That means after removing this, it would be like 1 2 3 and 3's pointer would, instead of pointing it to 4, would point to 5, right? So this will be our answer. In this case, we need to remove the first node from the end of the list. Okay. So the first node from the end of the list is this 2, right? So we will remove this 2 and we'll return 1 only. Okay. So I think you have understood the question. So 1 and 2 was there. So the first node from the end of the list we need to remove this. So we'll have only this 1. 1 would be pointing to null. Okay, this is null. So we remove this, 1 points to null. Okay. So now how do we solve this? If you would have to remove the nth node from the beginning, right? Say if this was the question, we have to remove it from the beginning. So in that case, we can remove this 2 directly, 1 can be pointing to 3, right? But here we need to do it from the back. Okay. So to do it from the back, we need to know the total length of the linked list, right? Then only if we start traversing from here, we will be able to delete that length. Okay, so you're getting the point. So if this is our linked list 1 2 3 4 and 5, okay, we need to remove the second element from this list from the back. Okay, now if we start from here, we don't know, we need to go to the back and we can't go back because this is a single linked list, right? So if we find this length, total length of the linked list, say the total length of the linked list is m, right? And now if we have this length as m and we need to remove this nth element, so this nth element is this one, okay? So if we need to remove this one, this nth element, and we are traversing from here, so if we do m minus n, then we will get this length, right? Because this is m and this is n, so this distance is actually m minus n, right? But when we start from here and when we need to remove this 4, we need to go previous to this element and then instead of pointing its node to this element, we need to point it to this one's next, this one, right? 3 will be pointing, instead of pointing it to 4, it needs to point to 5, right? So this will automatically be removed from the linked list, the single linked list, right? So actually we need to travel what distance? M minus n minus 1 distance. Total length of the linked list minus the n minus 1, okay? So this distance we have to cover and then we will just point this nodes next to nodes next ka next, okay? So let's code it. We'll take a backup node because we will be traveling. So say temp node is equal to head. Now what we'll do, we will say while head not equal to null, and we'll have int m, right, to find the length. While head not equal to null, m will be equal to 0 and head equal to head next. This is the way we find the length, you know it. n plus plus, we got the length. Okay. Also, if it's given that the value of n will always be greater than equal to 1. Okay. So if it's given that there is only one element in the linked list, okay, and n would be 1, so we have to remove this. So if heads next is equal to null, not heads next because head has become this, so this has to be like in the beginning. If heads next equal to null, then we return null, right? This is the condition. Okay. And then now we will have this list node. We need to change this head to temp again if we are traveling, because head is at the back. So now head is equal to temp. Okay. And now what we'll do, we will change this loop. Head is equal to temp. So while for int I equal to 0, we'll run in the loop. I is less than m minus n minus 1 I plus plus. We is starting from 0, so it will cover m minus n minus 1 distance, right? So head would be heads next. Right, so head would be head next. So here in this case, 5 minus 2 is 3. 5 minus 2 is 3. Actually, this 5 minus 2 is 3, right? So 1, 2, yeah. And so 5 minus 2 is 3, and 3 minus 1 is 2. So I should be less than 2, right? So it's starting from 0, 0, 1, 2. So 0, 1, and then 2. So it will reach 3. Okay, once it reaches 3, then we will make heads next would be pointing to this loop is over. Then heads next will point to heads next ka next. Right? Head next, 3 is next, will be pointing to its next. And then we will return return temp, because it is the starting point. Okay, and our solution is completed. Okay, so the link to the question is given in the description. Please try it yourself and then come to my code walkthrough section. Here is the code walkthrough of the 83rd question in the LeetCode platform. Remove nth node from end of list, and this question has been asked in these companies. And let's look at the solution, the one we have coded just now. Length equal to 0, and if heads next is null, we return null, and then we find the length. So we have taken it as length variable here, and then we have head is equal to temp, because we want again to traverse, we need to have this head. Here we have missed one, I missed one condition to write, that if the length is equal to n, right? So if the length is equal to n, then we need to make head is equal to return head next directly. Why? Because if the n is equal to the length of this thing, so if we start from here and this is equal to n, so that means this is the one, right? This is the node that we need to delete. So if we know that the length is directly n, so we don't need to compute this length minus n minus 1 and then directly delete it. Okay, because this would be the same thing, we won't be able to traverse it. So we will directly return the head next, and this from here we will return the loop. Okay, so this will help us to the complexity would be decreased, right? Directly we'll return if the length is equal to n. It can also be given in some question that here in this case it's given that the n is always less than the length of the linked list. But if it's not given, then if length mod n, we need to find that mod thing to find the exact value. N's value could be n mod length. Okay, so this is the same condition, length minus n minus 1. We proved this, how we need to traverse this much distance. Like if this n is equal to 2, right, we need to delete this 2. So this is 5 minus 2 is 3. So 3 minus 1 is 2. So we need to traverse. 1 should go here 2 one time and this one 2 times. So once you are here, you are done. Now you need to move its next to directly its next next 3 to 5. That's what we have done here. Okay, let's submit this. So it has been accepted. I think this solution is clear to you now. See you all soon in the next video where I'll be explaining the 84th question of the problem solving series. Jai Jinendra.